Good afternoon. Good afternoon, distinguished colleagues and guests. I'm very pleased to welcome you to this lecture, which is one of many going on this week and next, to welcome to our campus Dr. Samuel L. Stanley, the 5th president of Stony Brook University. These events are scheduled to celebrate his arrival and to spotlight the intellectual, artistic, and educational investments and pride points that Stony Brook has, and today is certainly one of those. As you all probably know, before coming to Stony Brook University, Dr. Stanley served as Vice Chancellor for Research at Washington University in St. Louis. He received his bachelor's degree in 1976 from the University of Chicago and his MD in 1980 from Harvard Medical School. After completing his internship and residency at Massachusetts General, he did postdoctoral work in immunology at Washington University and then joined the faculty in the Division of Infectious Diseases. Washington University, as you know, is one of the nation's most highly ranked schools of medicine, and while there, he had an outstanding reputation as a distinguished medical researcher and also published extensively. In his administrative role as Vice Chancellor for Research, Washington University's sponsored research funding reached nearly $400 million annually. While Dr. Stanley has extraordinarily impressive credentials in the medical research arena, those of us who have had the opportunity to work closely with him here are equally impressed with his understanding of and commitment to the academic enterprise. He truly understands the scope of what we do, from the lettered disciplines and the arts to science and medicine. I believe very strongly that he will effectively lead Stony Brook's efforts to build upon relationships with Cold Spring Harbor and Brookhaven National Laboratories to create our next generation of successes. He's articulate, thoughtful, deliberative, and strategic, and he's also a really nice guy to work for. It's a very exciting time for Stony Brook University, and I'm sure you join me in looking forward to Dr. Stanley's tenure and are confident that his presidency will bring many new and forward-looking opportunities to our institution. Thank you again for joining us for this historic celebration and to welcome our new president, Dr. Stanley.
Well, that was, thank you very much, Eric. That was really an extraordinarily kind introduction, and I really am pleased to be here. Those words, I think, were very wonderful, and this is the beginning of what I'm calling the Inauguration Marathon. I'm in my third or fourth event. I'll have to think about it for a second, but all of them have been very valuable. But these lectures are something I'm particularly looking forward to. I was saying to Dr. Pikitch before I came up, one of the things that I think sometimes happens to a president is that you get removed from the faculty. It becomes difficult to really see what's going on in the university, to really understand the scope and really appreciate the kinds of fascinating things that the faculty are doing. And of course, that's one of the reasons I came into academics and became a president to begin with. So it's really nice, I think, as part of my inauguration that I'm being pulled back in. And I do have to say something about what a pleasure it's been to work with Eric Kaler as our new provost as well. Eric, you know, is relatively new also. Is it 2.5 years or so now? But it feels longer. But he has been wonderful to work with, and I think is a tremendous partner. And you couldn't have a stronger advocate, I think, for the academic mission and what you're interested in at Stony Brook. So let me talk about our speaker this evening. So our speaker this evening is relatively new to Stony Brook, but she has very deep roots in New York. Dr. Ellen Pikitch grew up in Brooklyn and became fascinated with the sea and its inhabitants during summers spent on the beaches of Coney Island. So that in itself is a great story. Ellen has turned that childhood interest into dedication to saving the world's largest, most biologically rich place, its oceans. Let me begin by giving you a bit of background about Dr. Pikitch. She received a PhD in zoology and from there obtained a faculty position at Oregon State University. Subsequently, she moved to the University of Washington in Seattle, rising through the ranks to direct its Fisheries Research Institute. She returned to New York City to found and direct the Wildlife Conservation Society's Marine Conservation Program, building that enterprise to span 4 oceans in 19 countries around the globe. In 2003, Dr. Pikitch founded the Pew Institute for Ocean Science at the University of Miami and served as the Institute's executive director. Last fall, Ellen and the renamed Institute for Ocean Conservation Science made the move to Stony Brook. Dr. Pikitch continues as executive director and is also a professor in our School of Marine and Atmospheric Sciences, SOMAS. Ellen is a true pioneer who has devoted her life to innovative scientific research, but she has taken her research further, communicating her work broadly to influence real-world policy. Her contributions range from basic science innovations to significant domestic and international policy change, and let me give you a couple of examples. Dr. Pikitch's groundbreaking research proved that beluga sturgeon are near extinction due to their relentless pursuit of their caviar. She initiated and one of the petitioners who asked the U.S. government to list the beluga sturgeon under the U.S. Endangered Species Act. In 2004, the beluga sturgeon was in fact listed under the Act, one of the few species to receive this designation during the Bush administration. This listing made possible the subsequent ban on imports into the United States, which began in 2005 and continues to this day. Prior to this ban, the United States consumed 80% of the world's supply of beluga caviar, so this was a significant victory. On the heels of the U.S. decision, again largely spurred by Dr. Pikitch's long-term effort to save the sturgeon, a one-year international trade ban applicable to all wild species of sturgeon went into effect. In addition, Romania instituted a 10-year moratorium on fishing for sturgeon in its water. She's done more. Dr. Pikitch and her colleagues produced the first ever global estimate of sharks killed worldwide for their fins alone, up to 73 million per year. The Institute then helped secure international trade protection for great white sharks by developing DNA forensic tests to monitor the trade and prove that these ocean giants were being sold illegally. She spearheaded the scientific consensus on ecosystem-based fishery management. This is a holistic approach that emphasizes the interconnectedness of species and habitats and breaks from traditional species-by-species management. Dr. Pikitch is now serving as chairperson of the Lenfest Forage Fish Task Force. This team of preeminent scientists from around the world is developing approaches to sustainably manage these small schooling fish. Demand for forage fish has skyrocketed in recent years, and their depletion could truly cause a collapse of marine ecosystems. Ellen has led several major oceanic field expeditions and served on many high-level scientific panels, including President Clinton's panel on ocean exploration, the UN Task Force on Environmental Sustainability, and several committees of the National Academy of Sciences. She has authored or edited more than 100 articles and books on fisheries science and management. Her work has been recognized through numerous awards for scholarship, conservation, and communication, including the prestigious Pew Fellowship in Marine Conservation. I'm truly happy that Ellen decided to return home to New York and to bring her institute along with her to Stony Brook University. Please join me in warmly welcoming Dr. Ellen Pikitch.
Thank you, President Stanley, for that wonderful introduction. And I must say that I am deeply honored to be in this position of giving one of the inaugural lectures to welcome you to Stony Brook. And I'm sure that under your leadership, this already excellent institution will shine even brighter. Okay, so let me move to my first slide. The title of my talk, Stemming the Tide of Ocean Extinctions, pretty much gives away the punchline of what it is I'm going to talk about. And in a lot of places where I speak, people look and say, extinction in the ocean? Is that possible? And that's the theme I'm going to be addressing today. The idea that the oceans were so vast and limitless that nothing that we could do could ever hurt them, it's so ingrained in our thinking that it's become part of our everyday language. I can remember when I was a teenager and one of my boyfriends broke my heart, my mother consoled me by saying, "Don't worry, Ellen, there are plenty of other fish in the sea." Well, now I know that Mom was right about the guys, but she was wrong about the fish. We've come to realize that the oceans truly are in crisis. You've probably seen the headlines and heard the news that the amount of fish coming out of the ocean has reached a plateau in the 1990s and then started to decline. But what you may not know is what the story is about how many fish are left in the sea. So I'm going to use a couple of maps to illustrate that. This is a map showing the abundance of fish in the North Atlantic in the year 1900. And the way that you read this is the color says something about the density or the biomass of fish in different parts of the ocean. And red means lots of fish, more than 11 tons per square kilometer. And when we get down through the blue range, we're talking about an order of magnitude fewer fish, down to 1 ton per square kilometer. So you can see that off of our great coasts, the northeast coast, there are huge continental shelves. It's a great place to be a fish, and historically we had very high biomasses there. We also had very significant biomasses up in Canada, in Europe, in the North Sea, areas of red and green all throughout. Now let's look at the picture 100 years later in the year 2000. Quite a different picture. All throughout the North Atlantic, and this is typical of what's happened all throughout the world ocean, marine life has been disappearing. And just to get a side-by-side glimpse, again, of 1900, 100 years later, what's happened. How could it be that there are so few fish in the ocean and that we're still eating any fish at all? How come the world's fish catches haven't completely collapsed? Well, the reason is that fishermen are smart, and as they fished out one area and one species, they moved to another area and another species, and as time went by through sequential depletion, we managed to see the output staying pretty constant, but what was left in the ocean was greatly diminished. And if things keep going the way that they have been, we've literally been running out of places to go. We will see that collapse. One of the things about fishing, besides taking fish out of the ocean, is that there's some collateral damage that fishing can cause. And this is a schematic diagram of a very commonly used fishing gear called a bottom trawl. And this is hauled behind a fishing vessel. There are doors that keep the mouth of the net wide open. And it has a big sock that basically catches fish down in the end, in the cod end. And as this net is dragged along the bottom, it takes with it not only the fish that they're trying to catch, the fishermen are trying to catch as their target, but also it disturbs the seabed, takes in other marine life, and is a great source of destruction of habitat. Now, fishing technology has changed quite a bit in the past 100 years. There have been a lot of improvements in technology, and whereas 100 years ago we might have seen small-scale bottom trawling using sailing vessels, as the years went by with World War technologies being adapted by the fishing industry, we started to see where the places where fishing occurred moving off the shelves and deeper to the point where we're now seeing exploitation in the very deepest parts of the ocean. And here's an example of a deep coral forest off the Aleutian Islands, and just to show you visually what happens when a bottom trawl passes through a deep sea coral forest. So on the left-hand side, we see a spot that's never been trawled, and the next picture is the same exact spot 4 minutes later after one pass of the trawl. So again, it's a devastating picture. And what we really worry about with the deep sea is that it's a place where there's a very high degree of endemism and it's very low productivity. So when we see situations like this, we know it's going to be a long time to come before there could ever be a recovery. We might be losing species before we even have the chance to describe them, to know them, to see them. So, in fact, there have been ocean extinctions, and by the year 2003, more than 130 species of marine life extinctions have been documented. And what's really scary about this is that if you look at the time period over which these extinctions are being documented, more and more and more are being described. It seems as if extinctions are accelerating. The other thing is, it's kind of hard to call an extinction an extinction. Just think about it. How do you know when something is totally gone from the planet? You've got to look and look and look until you continue to not find it. And so typically there's about a 40 to 50 year time lag between the last sighting of a species and the time when scientists feel confident enough to say, this one's gone, it's extinct. So scientists are really fearing, given the vast increase in technology and fishing that occurred about 50 years ago, that we're now just beginning to see the edge of the wave of a gathering wave of ocean extinctions. Some of the things that we look at in the Institute for Ocean Conservation Science are fish that are really on the very brink of extinction. And these include the great sturgeons and the sharks. These fish have some things in common in terms of their life history. For one, they're very long-lived species, and they take a long time to reach maturity. In fact, for sturgeon, the average age of reproductive maturity is about 15 years of age, not very different from humans. And for sharks, we see ages of maturity in a similar range. So with this kind of life history, once these fish are depleted, it takes a long, long time to bring them back. To get into the sturgeon story a little more, sturgeons spend most of their lives in the sea, but most of them do come up into fresh water to spawn. And one of the earliest problems that sturgeon faced was the building of dams in rivers. And this shows just a small section of a dam that I visited on the Volga River in Volgograd. And right here was the idea that the officials had of how to mitigate against the effects of the dam. This dam stretch is actually 3 miles across the river, and it cut off 90% of the spawning habitat for the sturgeon in the Volga River, which historically is the most important sturgeon river in the world. Okay, so they built this fish elevator, and the idea was that the fish would come up to the elevator, wait for the doors to open, go into the elevator, wait for the doors to close, have the elevator go up over to the other side of the dam, and guess what? It didn't work. So dams cut off spawning habitat, but probably the most important reason why sturgeon are so endangered is because they are so valuable. The caviar that they produce is highly coveted, and for some varieties goes for more than $100 an ounce. The beluga sturgeon is the most valuable fish in the world. It's actually in the Guinness Book of World Records, and a female that was caught that had 900 pounds of eggs in her body cavity at $100 an ounce, that one female would have been worth $1.6 million. $1.6 million for a single fish. So when something is that valuable, it's almost a curse. It's really hard to conserve a fish that has that much value. And again, in the year 2000, the United States was the #1 consumer of beluga sturgeon caviar, even though this fish doesn't live anywhere near the United States. It lives in the Caspian Sea, Black Sea, and the Azov Sea. And so we reasoned that if we could do something in the United States to stem the demand for this product, we might have a chance of saving a fish that lived half a world away. So we came up with a project called Caviar mTOR, and it had 3 different components. The first was a consumer outreach component. We felt the consumers needed to know that they didn't have to eat the eggs of an endangered species. Even if they were caviar lovers, there were alternatives. And one alternative we pointed them to was farm-raised sturgeon, especially sturgeon that came from the west coast of the United States, where the farming practices themselves are very sustainable. And over the course of a few years of trying to get the word out through chefs, through restaurants, through magazines, we did find that we changed attitudes. And here's just one example in a magazine, Metropolitan Home: Old Classic, Caspian Sea caviar; New Classic, Sterling caviar, which is the farm-raised caviar of the white sturgeon from California. This campaign, this consumer education campaign, reached 250 million people and won an award. that is called the Silver Anvil Award, that is the highest award given by the Public Relations Society of America. Now, I have to say, as a scientist, the last thing I ever expected would be to get an award from the Public Relations Society of America, but this was recognized as being the best public information campaign in the year 2004. So we felt, okay, we've met with some success here. We have started to change attitudes. Beluga caviar was sitting on the shelves in delicacy stores, and the price and the quantity of the farm-raised caviar, the price was increasing, the quantity, they couldn't make the stuff fast enough. But was that really going to result in a permanent change, a permanent enough change for the fish? And so we had also petitioned the US government, asking them to list the beluga sturgeon under the US Endangered Species Act. And in 2004, the government went ahead and listed the beluga sturgeon as a threatened species. Now, one reason this designation was really important was that it allowed the United States to then start to do something about our imports. And by the following year, the US started to ban imports from several of the countries that were exporting beluga sturgeon, and by the end of 2005, the ban was complete. And now it wasn't necessary to keep getting the word out to consumers in the US anyway, not to eat the product, but they really couldn't get the product legally in the United States. And this ban has stuck, and it probably will stick, it will continue to stick until something is done to actually recover the fish. And following on the heels of the US action, the Convention on International Trade in Endangered Species went ahead and banned the trade of all species of wild sturgeon caviar throughout the globe in recognition of the scientific evidence that this group of fish was really in trouble and needed help, and also as a way to try to coax the nations that hosted sturgeon populations to do something to really improve the management and stop the decline. We've continued our work with sturgeon in a wide range of efforts, including work in Kazakhstan, with the beluga sturgeon itself, working with Kazakhstani scientists, and right here in our backyard in the Hudson River with the Atlantic sturgeon. And we are learning lots of things. So here's just one example from our work in the Hudson. We put some pop-off satellite archival tags on sturgeon that had gone into the Hudson River to mate. And these tags stay on the fish until they're programmed to pop off at a particular day and time. And when they pop off, they transmit all the information they've been collecting and saving up until that point, and then we then find out where they've been. And interestingly, we really didn't know where these fish would show up. And what we see is that the tags popped off at locations extending all the way up in Nova Scotia, down off the coast of Georgia. These are fish, again, that came to spawn in the Hudson River. So we've already learned that if we want to rebuild Atlantic sturgeon populations, we need to focus our attention on a very broad swath of ocean area. Okay, let's move on to another one of my favorite species groups, the shark. Sharks, again, long-lived, late to mature. They have an additional problem when it comes to being vulnerable to overfishing, and that is that their form of reproduction for the majority of species is very similar to humans. Most sharks give birth to live young, they have small litters, and so they have very, very low reproductive output. And I guess you could say that shark fins are the caviar of China. Demand for shark fins, which is used in shark fin soup, has skyrocketed, and it's the cartilaginous fin rays inside the dried fins that are used to make the soup. It's not even a flavor, not even the flavor of the fins, but rather just the texture that's being used in the soup. Our institute defined the scope of the problem by going into the markets in Hong Kong, where most of the shark fins transit through as they're processed, and using DNA tests to figure out what species of shark were being caught globally, looking at auction records. It was really a very complex program, And we came up with the first global estimate of the number of sharks killed solely for their fins, up to 73 million sharks per year. Okay, so as you can see here, when you look at a bunch of shark fins in a bowl, it's pretty hard to tell what species that might be from, or even if it may be from several species. And so our group has been working very diligently to try to find ways to identify sharks from their fins alone. And we've used DNA tests and developed markers to identify one species from another. This is an example of a test that was run to identify great white sharks. And what we were able to show, comparing fins of this species, this test compared with 68 species of very closely related sharks, we had 100% accuracy in identifying great whites compared with all others. And the test is fast and accurate and pretty inexpensive to use, and it works for great white sharks in the Atlantic, Indian, and Pacific Ocean. So when an enforcement agent called and said that they found a bag of shark fins in the United States, and they saw inside that the label said blanco, which means white in Spanish, and they wondered, could these be great white sharks? They gave our group a call. Now, the United States has banned the fishing of great white sharks for quite a long time. It is one of the leaders in terms of great white shark protection. So if those fins were great white shark fins, they would have been illegal. And our test was used and determined that these in fact were great white sharks. And one of the highest fines assessed for any wildlife crime was assessed, in this case, a $750,000 fine. So these methods are being used not only from a scientific perspective, but also they're being used to prosecute cases. Another use of this kind of DNA test is in getting international protection for great white sharks and other species. So the international trade is controlled by a convention, an international convention called CITES. They have a meeting every few years. And in 2004, I went to the CITES meeting in Bangkok, Thailand, where great white sharks were on the agenda for listing. Now, they'd come up a few times before and never quite made it. And one of the big obstacles to getting them listed was the fact that people would say, well, if we did get them listed, could we really monitor and enforce these regulations? And by having this DNA test and showing that, yes, in fact, we could tell great white sharks apart from all other sharks, we were able to get rid of that obstacle. And in 2004, the great white shark was listed on Appendix 2 of CITES. Okay, so while I think at this point we have pretty good protection for great white sharks domestically and internationally, scores of other shark species are in trouble. They're officially recognized by something called the IUCN as endangered, and we're now working in our DNA lab to develop tests for these other species so that they can enjoy the same level of protection the great white sharks have. I'm going to move now to a field study, a place that I've been working for more than a decade, and this is a place called Glover's Reef. Glover's Reef is off the coast of Belize. It's an atoll, and it's the southernmost atoll in the Belize Barrier Reef ecosystem. This is second only to Australia's Great Barrier Reef in size. It's a really important barrier reef. And also, the number of people who depend on this reef for food is much greater, actually, than the Australian Great Barrier Reef. So this Glover's Reef is a zoned marine protected area. And it has an area, the triangular area, which is a no-take zone. No fishing at all is allowed in that zone. And then most of the area is called a general use zone. So fishing is allowed, but the fishing that is allowed in that zone is done with certain restrictions. So there are size limits, there are quotas, there are season limits, depending on the species. But importantly for sharks, there is a prohibition on the use of gill nets and long lines all throughout the atoll. When I first came down here and said, I'm going to see if this marine protected area can have any benefit in the protection of sharks, my colleagues really laughed at me. They said, you know, sharks really move huge distances, and how could a little park like this make any difference at all in the conservation of sharks? And in fact, the great white shark I talked about, those sharks have been shown to migrate from off the coast of California to Hawaii and back, and there's been a great white shark seen off the coast of South Africa, tagged with one of those pop-off satellite tags that went all the way to Australia and all the way back to South Africa. So some sharks do indeed make very large transits. So it was a valid question. So what we set out to do initially was to develop an index of abundance of sharks at Glover's Reef. Every year we go down, we use research survey methods, we catch the sharks, we tag them, and we do it using the same methods in the same places year after year so that we can get some idea of how these populations are faring. And when I show this graph, most people say, wow, that's a really boring graph. I mean, look at what you see. This is the catch per unit effort, a measure of, or an index of abundance of the sharks, and here it is over time. And basically, there's no trend at all. The shark populations at Glover's Reef are stable. So people say, yeah, that's boring. I think this is really interesting because all around the world, shark populations are collapsing. That 73 million sharks killed per year just for their fins is having a very strongly documented impact, and we see declining populations everywhere around the globe. And the fact that we don't see that at Glover's Reef is what makes this place really interesting to me. Maybe the Marine Reserve is actually working and helping to protect sharks. So on the left here, this is a simple tag that we use that just has a number on it, an ID number, and we have to capture that shark again and look at the number to tell where we caught it last time. But for a period of years, we have been implanting what are called acoustic tags into the body cavity of these sharks. And these acoustic tags put out a signal, and that signal can be picked up by receivers. And okay, so let's say this is meant to stand for where the receiver is. This is what one of the receivers looks like, it's black elongated object. And these are placed where all these red dots are throughout the atoll. So we've got it pretty well covered. So here's what they look like under the water, the monitors, and they get pretty crusted over after they've been in the water for a while. There's a float that stays under the surface, but not too far from the surface so that we can locate them. And about twice a year, we go down, we retrieve the monitors, and we download the data, and we get a record of where each of those sharks has been. So again, to illustrate, if that represents one of those receivers, and there's a shark, and it happens to be one of those sharks with a tag implanted in its body that's putting out a signal, a unique signal. Each shark has a unique code that it's putting out. Then when that shark gets within range of the monitor will record its ID number, the date, and the time that that shark passed by. Okay, so what are we learning about the sharks at Glover's Reef? Here's an example. So that little blue box is a Caribbean reef shark, and that's where we tagged it. That's the location where we tagged it. And the height of the bars indicate how frequently that shark was heard from at each of those locations. So you can see that most of the time that the shark was heard from, it was heard from exactly where we tagged it. And we did see that it moved to some other areas and even to the outer reaches of the atoll occasionally. But this particular shark, the blue one, pretty much was a homebody. Okay, here's another shark. This shark outlined in yellow. And here's what the picture looks like for that one. Very similar picture to what we saw for the first shark. Again, most of the time that we heard from it right exactly at the spot where it was tagged. And while it did transit around the atoll, it liked to stay close to where we initially tagged it. And then to really bring the point home, here's another shark in red, and we see the same pattern. Here we have a group of monitors close together, and we see that the shark is really staying in a pretty small home range. So, whereas great white sharks make these enormous transits across ocean basins, Caribbean reef sharks, which really had not been studied until we started studying them, seem to spend a lot of time all in one place. We've done other studies which show that these sharks are residential all year round, in addition to the fact that when they're here, they do stay close to home. So, what's the conclusion of this study? Sharks do seem to be residential at Glover's Reef Atoll, and we believe because this is a marine protected area with the kinds of nets and gear that could catch sharks are prohibited, and there's also that no-take zone, that is the reason that we're seeing population stability inside this large marine protected area. And this, we feel, is a model of how parks can work for certain kinds of sharks. And it could be a good model for sharks in the tropics. If you look in the tropics, you find a high diversity of sharks, much higher than you do at other latitudes. And usually when you see a lot of diversity, it usually means that you've got more separation between populations. And it could be that what we see here for the Caribbean reef sharks is more typical of other tropical area sharks. So, the Glover's Reef Shark studies, we feel, provide a message of hope and also a model that could be transferred to other places, particularly in the tropics. And we're actively working to do that transfer ourselves. So we've extended our work on tracking sharks and working in other protected areas through the areas that you see here. And we have been successful in getting a key breeding lagoon protected in the Bahamas. And more recently, in Belize, where Glover's Reef is just one of many marine protected areas throughout a large marine system, the laws in place at Glover's Reef have been extended now throughout the Belize Barrier Reef ecosystem, and now 600,000 acres of marine reserves now exist, parks for sharks in Belize. So the model that we showed in one little spot of the globe is now being extended to a much broader area. We hope to move it even out of the Caribbean. I won't go into these projects today, but I would be happy to talk with any of you at another point. We are working on some of the smallest fish in the sea, the forage fish, the very foundation of marine ecosystems, because again, these are fish that, while they were largely ignored and not very valuable for a long period of time, are being exploited more and more. They now comprise about 37% of the world's wild marine fish catch, and out of that, 90% of those fish are being ground up into fish meal and fish oil and being fed to pigs, chickens, and also to other fish in aquaculture. We're also studying the waters in New York State. New York State has never had an observer program, and a lot of the things that happen out in the water don't really make it back to the land, and we don't get to see them unless we have the chance to observe what's going on out at sea. So I will come to a conclusion here and end by saying, what is the future going to look like? Will we be seeing this gathering wave of ocean extinctions? Will it be gathering steam? Or will we have a chance of saving species and saving much of the areas of the ocean? I think a lot of that depends on you. The decisions we make, especially over the next few years, are going to have a huge impact on what kind of ocean we face. And I'll leave you with this idea. There's still time to save the largest, most biologically rich place on Earth, but we better hurry. Thank you very much for your attention.